Hello, scientists. It's Mrs. Deming. I'm going to do this lab with you. There is a Kami version of it that you should be using to complete the lab. Looks like there's a little bit of a delay in my sound. We'll see how that works out. Okay, there is this background. I would actually read that after you watch the video. Okay, the first thing it tells us to do in activity 1 is pluck a guitar. Rubber band guitar. So it says to stretch a rubber band. It says actually do it between your pinky and your thumb, but that was really hard. So in class we did it like this, and we make some sounds by plucking the strings of our rubber band guitar, if you will. Okay, so it says to write down some observations. Write down some observations of the movement. You can do this with a rubber band that you have at home, a hair tie or something like that. Try moving your thumb and pinky closer and further apart. So this is kind of like what we did in the FET. And what happens is it makes different pitches. When I have it stretched really tight, it has kind of a high pitch. When I bring it together, it's looser, it has a lower pitch. So that's the answers for 1A, B, 2, 2A, and then you should answer those questions A, B, and C for activity 1. Activity number 2 says forks on a string. Okay, so this thing is called a tuning fork. It's a piece of metal. And if you look really closely on it, I don't know if you can see there are some letters. It has notes on them. This is I think that's a C, not a G, a C. And what happens when I tap this on the table, it makes a noise. It says, record the observations of what you hear and what you feel. So you guys can hear something, but what I can feel is this is vibrating in my hand. And I can probably make it so that you can see that. It's vibrating. You can hear it. I have a beaker here. Okay, so what I hear, a kind of humming noise, and it is vibrating. Through what material is it moving from this to my ear? So from here to my ear is air. Okay? And does it move towards or away from the source? So this is the source, and the sound is coming from the source outward. So it's going away. Okay, I have a pen on the desk here. Let's see if this will work with this pen. Maybe it'll work better with this one. It makes the pen roll away from the tuning fork, so it goes away. Okay. Pen, what are the ends of the tuning fork doing that cause this reaction? So the ends of the tuning fork are vibrating. In what direction does it push the pen away? In what direction does the fork push sound waves away? So this is the source, so it's coming off of this outward. The tuning forks have a string attached. I think you could actually try this with a regular fork in your house. So try it and let me know how it goes. So I have strings tied to the end, and this is going to look really weird, but I'm going to put them around the first knuckle of my fingers and kind of let this hang in between. And I'm going to stick my fingers in my ears, and then I'm going to hit this against the table. And it totally changes the sound, because now the sound is not just going through the air like we were hearing it before. It's much stronger going through the strings. So try that with a fork at home. Just tap the fork on the table, then do this thing where you've got the string tied on here, and then you put the strings around your finger. and you put your fingers in your ears and then tap it on there. Totally different sound. It's more of a, like, it's a louder, brighter sound. You can hear the tuning fork through your fingers and you can hear it through the string. Okay, the last thing you're going to do, and you're going to have someone help you do this at home, is you are going to put your ear, another weird thing was we were doing this in class, you're going to lay your head on the desk and then have somebody else on the other end of a table knock on the table and see if you can hear it through this ear that's touching the table and how that compares to how you hear it through your ear that is in the air. So the table is a solid, the air is a gas. Can you hear the knocking through the table? Yes. Could you hear the knocking through the ear facing the ceiling? Yes. Based on these observations, does the wave travel faster through solids or gases? I actually hear it better through the table, so I think it's going better through the solid. Why do you think sound waves would travel faster in solids than gases? I want you to think about the spacing of a solid. Okay, so think for a minute. We have solids, we have gases. What's the spacing of the molecules like? So in a solid, the molecules are much closer together. So if we're kind of in a longitudinal wave like sound is, the molecules have to kind of collide with each other. In a gas, the molecules are so far apart they can't even find each other. In a solid, they're already right next to each other. So just like in conduction, they find each other and pass the energy along. It's these collisions. So because the molecules are so close together in a solid, the solid is better at passing the sound waves along. Why does knocking on the table create sound waves? Because you're making a vibration that then travels through the table. Does sound travel away from its source or towards its source? Away from the source. You're going to draw what the tuning fork looks like. I think I just drew in this fork shape with sound waves coming off of it. Something like this. Last thing is we're going to put the tuning fork into some water. So I'll do this. And we do our tuning fork. And you can see that there's first a vibration in the water and then the water splatters. And then actually, if you can hear it, it's much closer. Let's see if we can splatter the camera. Changes, sound changes. See waves going out from the tuning fork. As energy is transferred, sound energy is transferred into the water, and that vibration splatters the water all over. Okay, I'd like you to use what I have said to finish this lab. You can read the front to answer the questions on the back, the sound conclusion questions. Hopefully that is helpful. If you have any other questions, please send me a message.